Welcome. So we're talking about the Laplace transform today. Okay, the Laplace transform. So first thing is, why on earth would we use this thing? So let me just introduce that real quick. So really there's two main reasons, and also this holds also for something called the Fourier transform, which is very similar. Okay, but we don't cover that in this course. You'll learn about that in another course. So first thing that this does is it takes a differential equation and it converts it to an algebraic equation. Okay, so in general, algebraic equations are going to be easier to solve than differential equations. So if we can make an algebraic equation, solve it, and then somehow come back and find our function from the algebraic solution, then we're going to be able to solve more problems. Okay, and the second thing it does well is it's able to handle discontinuities in the forcing function. And actually a specific type of discontinuity, what we call a jump discontinuity. Okay, we'll talk about what that is, but just those are two reasons that we would want to actually do this thing. So before we do any much more, let's just get right into doing some Laplace transforms. Okay, so what is the Laplace transform? Okay, well, most technically it is L of f of s equals the integral from 0 to infinity e to the negative st f of t dt. Now, typically, you're going to need at least that s is greater than 0 before we have any hope of this converging, okay? But one of the things that makes this flexible is, depending on what f is, we may still be able to make it convergent with other values of s. So we may have more restrictive values, but we at least need that. Sorry, dependent on f, we may need to further restrict s. And we'll talk about that as well. Okay, so let's start with just a very basic one, or the most basic one I can do. Let's take L of 1 of s. So here what we're taking is that our function f of t equals 1. Okay, so we're going to have the integral from, let me redraw my arrow there, my integral from 0 to infinity, okay, e to the negative st dt. Okay, and that's pretty simple. Okay, we do that using infinite integrals. So limit as t goes to infinity. Okay, the antiderivative of e to the negative st is e to the negative st over negative s from 0 to t. Okay, so that's going to equal what? 1 over s times e to the 0 is 1 minus e to the negative st. Oops, I forgot my limit. God, I don't know how I'm going to teach when I go back and don't have a lasso on my board. Okay. And so this thing is going to go to 0 as t goes to infinity. Okay. And the reason that works is, of course, because s has to be bigger than 0. Okay. If s was less than 0 or equal to 0, that's not going to give us anything. That's going to give us 0, actually. Okay. If s equals 0, then we can't do this integral. Okay. So we get 1 over s if s is bigger than 0. Okay, that's our first one. Let's do another one. Let's take example. Let's take L of e to the at of s. Let me write that a little better. Okay, so here our f of t is e to the at. All right, so we're going to go ahead and take that Fourier transform is going to be the integral from 0 to infinity, okay, of e to the negative st, e to the negative, I'm sorry, e to the at dt. Now this is almost the exact same integral that we just did, okay? Sorry, this is bothering me that s looks so ugly. Okay, so this is actually almost the exact same integral that we just did. So if we write this, this is going to be the limit as t goes to infinity, okay, the integral from 0 to t, e to the negative. Now I'm going to write that as s minus a t dt, and I just double check. I'm supposed to have a net positive on a, negative times a, so I'm good. I just want to make sure, always make sure I'm, sanity check. Okay, that equals the limit t goes to infinity, e to the negative s minus at over negative s minus a from 0 to t. Okay, so now when I do this integral, what do I need in order for this to converge? In order for this to converge, I need my s minus a to be bigger than 0. Okay, so that's going to equal almost the exact same thing. When I plug 0 in, I get 1. So let me write that. Sorry. 1 over negative s minus a e to the negative s minus at minus, let me move this over a little bit, minus e to the negative 0, so e to the 0. Ah, Again, forgetting my limit as t goes to infinity. Okay, good thing I'm not grading myself because I'd be hemorrhaging points. Okay, so now as t goes to infinity, this is going to go to 0, and you're going to get 1 over s minus a, and this only works if s minus a is bigger than 0, so s should be bigger than a. Okay? So those are our first couple. We're going to do a couple more, but I'm going to go ahead and go to a new video and switch the page. Okay? See you in the next video.